this video, we are going to solve some problems in number bases. That is all WASSCE problems in number bases. So we have this problem, which is express 441 base 5 as a number in base 4. So to be able to do this, we need to first convert 441 base 5 to base 10, and then from base 10 we'll convert it to base 4. So let's convert 441 base 5 to base 10. So what we do is that we say this is 4 times 5, put it in one bracket, add it to 4 times 5, that is this 4, and then put it in another bracket, then add it to 1 times 5. So you start from the last one, which is 0, 1, and then 2. So you see that 5 exponent 0 is 1, 1 times 1 is 1, and plus 5 exponent 1 is 1, 5. 5 times 4 is 20, then plus 5 exponent 2 is 25. 25 times 4 is 100. So 100 plus 20 plus 1 will give us 121. So 441 in base 5 equals 121 in base 10. So now let's convert this to base 4. So in converting it to base 4, we need to draw our table here. So we are talking about 121, and then we are taking it to base 4. So you see that if we put 4 here, 4 times 30 is 120. So it will be left with a remainder of 1 here. And then 4 times 7 is equal to 28. So 30 minus 28 is 2, so remainder 2. Then 4 times 1 is 4. Now 7 minus 4 is 3. So there's a remainder of 3 here. So because 4 can no more go into this to give us a whole number and a remainder, then we'll repeat that here. So when you are writing, you write from the bottom to the top. So this becomes 1, 3, 2, 1 in base 4. So therefore 441 in base 5 is equal to 1, 3, 2, 1 in base 4. So let's continue with this question. If 123 base x is equal to 38 base 10, find the value of x. So 123 base x is equal to any number that is written without a base is in base 10, so we can say it's equal to 38. So just as we did in the previous example, this becomes 1 times x, put it in one bracket, then plus 2 times x, put it in another bracket, then plus 3 times x, put it in another bracket, and that is equal to 38. So you start from here. Here is 0, 1, and then 2. X exponent 0 is 1. 1 times 3 is 3. And plus x exponent 1 is x times 2. So here becomes 2x. Then x exponent 2 is x squared times 1 is 3x squared. So plus x squared. And this is equal to 38. So let's bring 38 to the left hand side. So it becomes x squared plus 2x. Then 3 minus 38 is minus 35 equals 0. So we need to look for two numbers that when you multiply, you get minus 35. But when you add, you get plus 2. So you see that 7 times minus 5 is minus 35. However, 7 minus 5 is 2. So we have in one bracket x plus 7, then times another bracket x minus 5 equals 0. So the values of x are x equals minus 7 or x equals 5. But for number bases, we cannot have negative numbers. So it is always x greater than 0, and therefore x cannot be equal to 7. So the true value of x is x equals 5. Solve for x. 133 base x is equal to 43 base 7. So because this is not in base 10, what we need to do is to convert it to base 10. And we already know how to do it. And then we also convert this one to base 10. So this becomes 1 times x then plus 3 times, 3 times x in another bracket, then plus 3 times x in another bracket. This is equal to 4 times 7 in one bracket, then plus 3 times 7 in another bracket. So here is 0 and here is 1. Here is also 0, here is 1, then here is 2. So now 7 exponent 0 is 1. 1 times 3 is 3. Then plus 7 exponent 1 is 7 times 4 is 28. This is equal to x exponent 0 is 1 times 3 becomes 3. And plus x exponent 1 is x times 3. Here becomes 3x. Then plus x squared. Then times 1 is still x squared. So now you see that 28 plus 3 is 31. So here becomes 31. Then here becomes x squared plus 3x and plus 3. So if you bring everything to the left hand side, this becomes x squared then plus 3x. Then 3 minus 31 is minus 28 equals 0. So now we look for two numbers that when you multiply, you get minus 28. But when you add, you get positive 3. So you see that 7 times minus 4 is minus 28. However, 7 minus 4 is 3. So here becomes x plus 7 in one bracket. Then times x minus 4 in another bracket equals 0. So the values of x are x equals minus 7 or x equals 4. Nonetheless, in number basis, the base cannot be a negative number, so x cannot be 7. So the true value of x is x equals 4. Solve for x if 233 base x is equal to 125 base 7. So now, we have 2 times x, put it in one bracket, then plus 3 times x, put that also in another bracket, plus 3 times x, put that in also another bracket. This is equal to 1 times 7. We are converting this 125 base 7 to base 10. Then plus 2 times 7. Then plus 5 times 7. So here is 0, 1, and then 2. This place is also 0, 1, and then 2. So you can see that 7 exponent 0 is 1. 1 times 5 is 5. And plus 7 exponent 1 is 7 times 2 is 14. 7 exponent 2 is 49. So 49. And this is equal to x exponent 0 is 1. 1 times 3 is 3. Then plus x exponent 1 is x times 3. Here becomes 3x. Then plus x exponent 2 is x squared times 2. So this becomes 2x squared. So we now have 2x squared. Then plus 3x plus 3 equals. Now 49 plus 14 will give us 63. 63 plus 5 is 68. So if we bring 68 to the left hand side, we now have 2x squared, then plus 3x. Then 3 minus 68 will give us minus 65 equals 0. Now 2 times minus 65 is minus 130. Now two numbers that if we multiply, we'll get minus 130, but if we add, we'll get 3. So you see that 13 times minus 10 is minus 130. However, 30 minus 10 is 3. So therefore, here becomes 2x squared, then plus 13x minus 10x minus 65 equals 0. So with here, we can factorize x out. So we are left with 2x plus 13. Then with this place, we can factorize minus 2 out. Then we are left with, here is left with, we can factorize minus 5 out. Then we are left with 2x plus 13 equals 0. So in one bracket, we have x minus 5. Then in another bracket, we have 2x plus 13 equals 0. So the values of x are x equals 5 or x equals minus 13 over 2. Just as we established previously, we don't allow negative values as base, and therefore x cannot be negative 13 over 2. So the true value of x is x equals 5. If 136 to base n is equal to 76, find n. So 136 base n is equal to 76. Now, just as I said, now if you see any number without a base attached to it, it's in base 10. So we need to convert this 136 to base 10 such that it can be equal to that 76. So this becomes 1 times n, then plus 3 times n, and then plus 6 times n. And all of this is equal to 76. So here 0, 1, and then 2. So now, n exponent 2 is n squared times 1. We still have n squared. Then plus 3 times n exponent 1 is 3n. Then plus n exponent 0 is 1 times 6 is 6. This is equal to 76. So if we bring 76 to the left-hand side, it becomes n squared. Then plus 3n minus 6 minus 76 is 70 equals 0. So two numbers that when we multiply, we'll get minus 70. But when we add, get plus 3. So you see that 10 times minus 7 is minus 70. However, 10 minus 7 is 3. Therefore, in one bracket, we have n plus 10. Then in another bracket, we have n minus 7 equals 0. So the values of n are n equals minus 10 or n equals 7. And just as we said, the base cannot be a negative number. So n cannot be negative 10. So the true value of n is n equals 7. Given that 211 base c is equal to 320 base 4, find the value of c. So we have 211 base c equals 320 base 4. So convert this side to base 10 and convert this side to 2 base 10. So this becomes 2 times c plus another bracket 1 times c and plus 1 times c again. This is equal to 3 times 4 plus 2 times 4 then plus 0 times 4. So here 0, 1, and then 2. Here's also 0, 1, and then 2. So let's start from here. C exponent 0 is 1. 1 times 1 is 1. And plus C exponent 1 is C. C times 1 is C. And plus C exponent 2 is C squared times 2. Here becomes 2C squared equals, now 4 exponent 2 is 16. 16 times 3 is 48. Then plus 4 exponent 1 is 4. 4 times 2 is 8. Then 4 exponent 0 is 1. 1 times 0 is 0. So now this becomes 2c squared plus c and plus 1 equals 48 plus 8 is 56. So 2c squared plus c, then 1 minus 56 is minus 55 equals 0. So now you see that 2 times minus 55 is 100 minus 110. So two numbers that when you multiply, you get minus 110. But when you add, you get 1. So you see that 11 times minus 10 is minus 110. And 11 minus 10 is 1. So this becomes 2c squared plus 11c minus 10c minus 55 is equal to 0. So now, let's factorize c from here. We are left with 2c plus 11. Then minus, let's factorize 5 from here. We are left with 2c plus 11 equals 0. So in one bracket, we have c minus 5. And in another bracket, we have 2c plus 11 equals 0. So the values of c are c equals 5 or c equals minus 11 over 2. But we know that we don't allow negative numbers as the base, and therefore c cannot be equal to minus 11 over 2. So the true value of C is equal to what? 5. 124 base n is equal to 232 base 5. Find the value of n. So here becomes 1 times n, then plus 2 times n, then plus 4 times n. This is equal to 2 times n and plus 3 times n. Sorry, 2 times 5. The base here is 5. Sorry. Then plus 3 times 5. Then plus 2 times 5. So here is 0, 1, 2. Here's also 0, 1, then 2. So 5 exponent 0 is 1. 1 times 2 is 2. And plus 5 exponent 1 is 5 times 3 will give us 15. And plus 5 exponent 2 is 25 times 2 is 50. This is equal to n exponent 0 is 1 times 4 give us 4. Then n exponent 1 is n times 2 give us 2n. And plus n exponent 2 which is n squared. So this becomes n squared plus 2n plus 4 equals 50 plus 15 is 65. 65 plus 2 is 67. So if we bring 67 to the left hand side, it becomes n squared plus 2n, then plus 4 minus 67 will give us minus 63 equals 0. Now two numbers if you multiply, you get minus 63. If you add, you get 2. So you see that 9 times minus 7 is minus 63. And then 9 minus 7 is 2. So here becomes in one bracket n plus 9. Sorry, in one bracket n plus 9 n times in another bracket n minus 7 equals 0. So the values of n are n equals minus 9 or n equals 7. But n cannot be minus 9 because we don't allow negative values as the base. Therefore, the true value of n is n equals 7. Draw a multiplication table in base 6 on the set 1, 2, 3, 4. From your table, solve alpha 2 times x equals 2, and then beta m times m equals 4. So let's consider this as our table. So it is a multiplication table, and then the set is 1, 2, 3, 4. So you repeat the same thing down here. 1, 2, 3, 4. So 1 times 1 is what? It's 1. But we are doing it in base 6. 1 is less than 6, so we write it. 1 times 2 is 2. 2 is less than 6, so we write 2 here. 1 times 3 is 3. 3 is less than 6, then we write down 1, 2 here. And 1 times 4 is 4. 4 is less than 6, we write down 1, 2 here. 2 times 1 is 2. And 2 times 2 is 4. 4 is less than 6, so we write it. 2 times 3 is 6. Now, 6 divided by 6 is 1, remainder 0. Then 2 times 4 is 8. Now, you see that 8 divided by 6 is 1, then remainder 2. 3 times 1 is 3. 3 is less than 6. And 3 times 2 is 6. Now, 6 divided by 6 is 1, remainder 0. Then 3 times 3 is 9. 9 divided by 6 is 1, remainder 3. And 3 times 4 is 12. Now, you see that 12 divided by 6 is 2, remainder 0. And 4 times 1 is 4. 4 is less than 6. 4 times 2 is 8. 8 divided by 6 is 1, remainder 2. Then 4 times 3 is 12. 12 divided by 6 is 2, remainder 0. Then 4 times 4 is 16. 16 divided by 6 is 2, remainder 4. And now the second part says that from our table we should evaluate 2 times x equals 2. So now we need to come to this 2 column and find where we can find 2. So you see that we can find 2 here. So 2 times what number will give us this 2? It is 2 times 1. So therefore, from alpha, x is equal to 1. Then let's come to beta. says that m times m is equal to 4. So now we need to come and locate the places where we have 4 in this table. So we have 4 here. We also have 4 here. And apart from that, we also have 4 here. Nonetheless, the question is saying that m times m. So that means that a number times itself will give us the 4. If we come to this 4, you see that it is 1 times 4. 1 and 4 are not equal. So that means this 4 is not the one we are talking about. Then let's come to this 4. It is 4 times 1. Now, 4 is not equal to 1. So this 4 is not also correct. But if you come to this 4, you see that it is 2 times 2. And 2 is equal to 2. So therefore, beta is m equals 2. Because 2 times 2 will give us 4. So 2 times 2 is equal to 4. If 110 base x is equal to 1020 base 4, find the value of x. So now you can pause the video and try to solve the question. Post your answer in the comment section and I'll give you a shout out. So now, what we need to do is that we have 110 base x equals 1020 base 4. So we need to convert this number to base 10. And then we also need to convert this number to base 10. And then we can equate the two. So in converting it to base 10, this part becomes 1 times x. Put it in brackets, add it to 1 times x. Put it in brackets, add it to 0 times x. Then this is equal to this 1 times 4. Then plus this 0 times 4. Then plus this 2 times 4. Then plus the last 0 times 4. So now what we'll do is that starting from here becomes 0, 1, 2, and then 3. Then this is also a different term. So it here becomes 0, 1, and then 2. So here 4 exponents 0 is 1. 1 times 0 is 0. Then plus 4 exponent 1 is 4 times 2 is 8. Then plus 4 exponent 2 is 16. 16 times 0 is 0. Then plus 4 exponent 3, that is 64. This is equal to x exponent 0 is 1. 1 times 0 is 0. And plus x exponent 1 is 1. Sorry, x exponent 1 is x. X times 1 is x. Then plus x exponent 2 is x squared. X squared times 1 is still x squared. So we will now have x squared plus x equals 64 plus 0 is 64. And plus 8 will give us 72. So here is 72. So if we bring 72 to the left hand side, it becomes x squared plus x minus 72 equals 0. So now we need two numbers that when you multiply, you get minus 72. But when you add, you get plus 1. So you see that 9 times minus 8 is minus 72. However, 9 minus 8 is 1. So here becomes x squared, then plus 9x minus 8x minus 72 is equal to 0. So if we factorize x out of this place, we have x plus 9. Then for here, we'll factorize minus 8. We get x plus 9 here, equals 0. So we have two brackets. One bracket is x minus 8 and times x plus 9 equals 0. So the values of x are x equals 8 or x equals minus 9. Nonetheless, in number bases, we don't allow the base to be a negative number. X must always be greater than 0. And therefore, x equals minus 9 cannot stand. So the true value of x is x equals 8.